For this lab, I analyzed the motion of a dropped object and determined how energy is conserved throughout. To analyze this, I dropped an object and extracted position points and then plugged it into a glow script code to get how observed position and predicted position relate to one another and to see if energy is conserved. And to do so, I used Newton's second law and energy principles. So for formulas, we use Newton's second law, force of gravity, F net, kinetic energy, gravitational potential energy, and total energy equations. So for tracker, I actually analyzed my video from lab 2 and I was able to reanalyze this and just make sure my position points were super accurate and then put these position points into a CSV file to transfer it into my GlowScript code. So for GlowScript page 1, I plugged in the mass of the ball, the initial position vector, and the initial velocity. And for my GlowScript code, I actually used the code from lab 4. I just edited this to now reflect a dropped object and not a spring. So for page 2, I plugged in equations for kinetic energy, gravitational potential energy, total energy, gravitational force, net force, Newton's second law, position update formula. And for page 3, I plugged in again our energy equations as well as our change in energy equations. And then I was able to run my code and put the CSV file into the GlowScript code to transfer those position points into the code. So for computation model, I got observed versus predicted motion of the x and y direction and our change in energies. So for our position and versus time graphs and our motion in the x and y directions, they're relatively the same, except for our y position is a little bit off. The model and experiment are a little bit different, and I think that's because I did not incorporate the drag into this code, but they are relatively going in that negatively downward direction. So for results, our delta E does remain at 0, so energy is conserved, and our delta K begins to increase, and our delta U, or our delta positional energy, decreases throughout. And we can see that those can be summed to equal 0 and can cancel each other out. And I thought this was really interesting to see how when the ball drops, that velocity accelerates, and the delta K increases, and then as it falls, the potential energy does decrease since it's a lower height. So what does this mean? So is the energy principle satisfied? Yes, the energy principle is satisfied and that delta E does remain at 0. And what really changes when the object is dropped from if the object had been dropped from different heights? So the different heights would affect how much kinetic and potential energy there was, especially with the potential energy shifting as it is lowered. So if it is dropped, I think that the kinetic and potential energy would not really reach that maximum as it did when it's dropped all the way from a larger height to the ground. And this would also vary if the ball was caught before it touched the ground. This would not allow the kinetic and potential energy to reach their max height. However, the energy would continue to be conserved since the potential and kinetic energy are linear and going in those two linear lines, both negative and positive. They would continue to cancel each other out and get that delta E of 0. So what if the object had been rolled vertically? So if the object was rolled, we would need to change our GlowScript code to reflect a change in x-axis instead of a change in y-axis. And also we need to consider that a ball being rolled, the potential and kinetic energy is not so much focused on the force of gravity. It's instead focused on how the ball is rolling. So we'd also need to change up our code to reflect that. So I actually did plug in a rolled ball into my GlowScript code, and as you can see, we don't really get a delta K or delta U gravity because it's not really affected by gravity since it's just rolling. So critiques and conclusions. For this lab, I originally planned to compare the potential and kinetic energies of a dropped and a rolled object. However, after multiple trials and errors and trying different GlowScript codes, I realized that the kinetic and potential energies are found in two completely different ways, with an object being dropped mainly focused on the gravity, an object being rolled mainly focused on how the object is rolling and the different angles involved in that. And I realized that one would be very heavily affected, again, on gravity, and one heavily focused on rotation, so it would be kind of hard to compare those values using the same GlowScript code I had created. So I decided to link in that still rolled ball to put it in for our what does it mean and what if sections of the lab. So during this lab, I was able to determine how energy is conserved when the ball is dropped and see how potential and kinetic energy changes, but I was also able to realize through trial and error how different ways of motion can change the kinetic energy and potential energy while they are still conserved. However, those ideas and equations can change.